We are picking up with number 12 in section 3.3 in this video for Achieve. For problem 12 here, it's another product rule where we have the square root of x plus 2 times the square root of x minus 1. So when I thought about that, I had a couple of options. I could have went ahead and did the algebra first and distribute through and then take the derivative, which would have been easier. But the point of this section is to take the derivative using the product rule. So I went ahead and did it with the product rule. And that's going to require us to write as powers. The square root of x is just x to the 1/2 in each of these groups. So we have x to the 1/2 plus 2 times x to the 1/2 minus 1. Now, when I take the derivative with the product rule, I have to say, well, that's the derivative of the first. Derivative of that first group is the derivative of x to the 1/2 power, which is 1/2 x to the negative 1/2. Then, of course, derivative of 2 is 0. So this is the derivative of the first times the second plus the first, the x to the 1/2 plus 2, times the derivative of the second term, which is, again, 1/2 x to the negative 1/2. After we did that, you needed to go through and use the distributive property to multiply. So when I multiply this first one, I like this one. Remember, anytime you multiply like bases, you add their exponents. When you add their exponents, you're going to get x to the 0 power. So the variable cancels out of this, and you just say, well, you're going to have 1/2 times 1 for 1/2 there. Then, of course, you're going to have minus 1/2 x to the negative 1/2 when you distribute into the second term. Over here, when I distribute, this x to the negative 1/2 again cancels with this x to the positive 1/2, but we're left with another positive 1/2 coefficient. The x canceled out. For the second term there, 2 times 1/2 is going to give me 1 as the coefficient, and then I'll have my x to the negative 1/2. Now, when I'm looking at that, putting my answer in descending order, well, the constants are of higher power x than the negative exponents are, so I went ahead and did them first. 1/2 plus 1/2 is 1. And then I have negative 1/2 x to the negative 1/2 plus 1 x to the 1/2. So I just said, well, that's 1 minus 1/2, which gives me positive 1/2 x to the negative 1/2. And then, since the original was put in radical form, my final answer really should be in radical form. And I need to understand that 1 over 2 x to the negative 1 over 2 is the same thing as 1 over 2x to the 1/2, which is better written as 1 over 2 on the root of x. So my final answer there, 1 plus 1 over 2 root of x, gorgeous answer there. And then once you get that in, Achieve will like it. For the next question here, number 13, it gave me one in which I was supposed to use the quotient rule. My problem was 4x to the 5 over 2 minus 3 divided by x. So as always with the quotient rule, I squared the denominator. Bring that denominator up to the numerator times the derivative of the numerator. Well, the derivative of the numerator is just going to be the derivative of 4x to the 5 over 2. I said 5 over 2 times 4, that's 20 divided by 2 for a coefficient of 10. And then x to the 5 over 2 minus 1 power gave me 10x to the 3 over 2 when I subtracted 1 from that exponent. Now, of course, derivative of 3 is 0, so we just get our derivative of the high function right here, low d high, minus high, the numerator, times the derivative of the low function, or derivative of the denominator, which is simply 1. Now, when I tried to simplify, I distributed in the first group, x times 10x to the 3 over 2 gave me 10x to the 5 over 2. Then we're subtracting this group, minus 4x to the 5 over 2 and plus 3. Of course, we have two terms of x to the 5 over 2, so we combine their coefficients to give us 6x to the 5 over 2 plus 3, all divided by x squared. And unlike the previous problem, I would feel no obligation to put this answer in radical form because the original question was not in radical form. So I would just leave it just like this, and you can see that's what I did on Achieve here. Now, the next question on Achieve, and let me scroll down, you'll see it took me 3 attempts. And the reason is because, I'll show you here, I wrote it wrong. So I tried to work the wrong problem, and then I was so sure that my answer was right, I put it in there twice until I realized, nope, I wrote the problem wrong. So this number 14 is a beautifully worked, gorgeous problem, but it's not the problem that they wanted me to work. And since I use pen, I couldn't erase it. So the real number 14 is right here. This is what Achieve wanted me to do. It gave me the function h of t is equal to t, not 1, over t plus 4 times t squared plus 4. Now, if I were just doing this problem of any method, it would really be best and easiest to go ahead and FOIL out that denominator and work with that. But I tried to keep it with how Achieve would want me to work the problem, and I really want to do the quotient rule and product rule wherever I can. So I left everything as it is and didn't algebraically simplify, and I just took my derivative. Now, whether you algebraically simplify or not, your final answer is going to be the same. It just be in a slightly different format of the answer. But now I can go in and say, well, if I leave my original problem like they intended, the derivative says we're supposed to square the denominator. That's what I did. Then the derivative says we're supposed to bring that denominator up to the numerator times the derivative of the numerator. Well, derivative of t with respect to t is 1. So this is the denominator times the derivative of the numerator minus the numerator. I often like to say low d high minus high d low over low low. So low d high minus high. Now, d low, well, that means derivative of the denominator. Now, the problem with that is I had to show that as a group because it's a product we're trying to take the derivative of. So this is a problem in which we're going to have to take the derivative of the product rule within the quotient rule. So I had to show that I will be taking the derivative there. I have not yet. So this is low d high minus high. I will take the derivative of the low over low low. Now in the next step, what I did is I went ahead and FOILed out these because I knew it would have to be done eventually anyway. And then I have minus t times the derivative of the denominator, which I had to use the product rule. Here I used the product rule. Derivative of the first is 1 times the second plus the first, t plus 4, times the derivative of the second, 2t. Now I have algebra even within that group to simplify. So you can see here, I took my t squared plus 4 plus, this would give me a 2t squared plus 8t, and then I'm multiplying all of that by a t on the outside. So that's what I've shown in this step. This is just the first 4 terms I already had there. And then I said minus, and here is where I just simplified what was inside the group, but then I needed to multiply it by a t, and it doesn't matter whether I put the t out in front or at the end, either way. But I went ahead and showed what it's equal to after you multiplied by the t up here, just so I wouldn't have to show yet another step. And then I can say, okay, I'm going to have t cubed minus 3t cubed for minus 2t cubed, 4t squared minus 8t squared for minus 4t squared. I'll have 4t minus 4t, the t terms cancel out. Then I'll have 16, and then there's no constant up here because all of it was multiplied by t, so I just bring down my 16. So I have my trinomial and my numerator done over that denominator squared, and you'll see that instead of writing it as a group squared, I thought it looked better just to go ahead and then square each individual term like that. Achieve would have accepted the answer with either format. But now I can see that absolutely, third try since I wrote it wrong, that in the original problem, that Achieve did like the format of this answer. Now, 415 here gave me a product rule problem. So I can say For this one, f of x is equal to x to the 3 over 2 times the trinomial 10x to the fourth minus 7x minus x to the negative 1/2. So first thing I did, I went ahead and said, well, let's use the product rule. That means I take the derivative of the first term, 3 over 2x to the 1/2 times the second, plus the first, now times the derivative of the second, and that's where the 40x cubed minus 7, and then be careful with that last term. Negative 1/2 comes down in front, makes that positive 1/2, and then x to the negative 1 over 2 minus 1 power becomes x to the negative 3 over 2 power. Now, at this point, the derivative has been taken correctly. You just need to simplify. You can't ever leave any multiplication in there unless it's a factor. Nothing is a factor right now. So I have to distribute out the first group, distribute out the second group. When I distribute the first group, 3 over 2 times 10, that's going to give me 30 over 2, which is 15. X to the 1/2 plus 4 power. That's the 4.5 power, which is better written as the x to the 9 over 2. So I have 15x to the 9 over 2. And then 3 over 2 times negative 7, that's minus 21 over 2. X to the 1/2 times x to the first is x to the 3 over 2. And then my last term here, you've got 3 over 2 times a negative 1 for a minus 3 over 2. And then the x terms just cancel each other out because you have x to the 1/2 times x to the negative 1/2. So we have our first three terms taken care of. I move to find the next three terms by distributing x to the 3 over 2. When I distribute it into the first term, 3 over 2 plus 3 there in the exponent, that's going to give me 3 over 2 plus 6 over 2 is x to the 9 over 2. You can see we just have our 40x to the 9 over 2. When I distribute into the second term, you're just going to have your minus 7x to the 3 over 2. And when you distribute x to the 3 over 2 into the last term, yet again, your x terms cancel out, but you still have the coefficient there. You would have plus 1/2 x to the 0, which is better written as just plus 1/2. Now, combining like terms, you have x to the 9 over 2. I combine their coefficients, I get 55x to the 9 over 2. I have 2x to the 3 over 2. When I thought about this, I just said, well, this is negative 21 over 2. This is the same thing as minus 14 over 2. Negative 21 over 2 minus 14 over 2 gave me minus 35 over 2, x to the 3 over 2. And then we have negative 3 over 2 plus 1 over 2. That's minus 2 over 2. Should be, let's see here, guys. According to this, it should be minus 1, and I have a plus 1, and Achieve accepted my answer. Let's see. It would be a negative 3 over 2 there. And then I have plus 1/2. That should be a minus 1 there. Very strange. I wonder if Achieve made the same error I did. That is weird because that answer is not correct there, but Achieve thought it was correct. And so now don't get confused with how to work the problem. The problem's pretty easy. I just made a simple little numerical mistake there, and Achieve liked my numerical mistake. So I will let the developers of Achieve know that there's an error in this problem because that answer should not have been marked correct. It should be minus 1 there because the negative 3 over 2 plus 1/2. And there's no other constant in that. So that problem's bugging me now. I don't like it to count problems correct that are incorrect. And that's precisely what it did there. Now, let's go on to the next problem. For 16 here, it gives me pi squared times 4x minus 7. This one's really so easy, I could see some people getting confused with it. It's really not a product rule, but you can think of it as a product rule. A product rule is when we have a product of differentiable functions. This first term is not a differentiable function, it's just a constant, pi squared. we know that that's just 3.1415927 quantity squared. So that's just a constant. It's an irrational constant, but it's a constant. And we know that the derivative of any constant is 0. So the way I showed my work here is I said, well, the derivative of the first is 0 times the second plus the first, pi squared, times the derivative of the second. Well, the derivative of 4x minus 7 is 4. So you can see here, this 0 times anything makes that whole first group 0. So I just get 0 plus 4 pi squared. Final answer of 4 pi squared. Piece of cake. Up next, 17. 17, I like this question. I like it, I like it, I like it. The 3-term product rule. So no matter how many terms you're taking the derivative of, I need you to understand, if you were taking the derivative of 4 terms, you'd say, oh, derivative of the first times the other 3, derivative of the second times the other 3, derivative of the third times the other 3, derivative of the fourth times the other 3. So it really doesn't matter how many terms you have in your product that you're multiplying with. The product rule says that you're only going to take the derivative of one at a time, multiplying the other ones without the derivative. So if I have a 3-term product here, I say it's the derivative of the first times the second times the third, plus the first times the derivative of the second times the third, and then I have plus the first times the second times the derivative of the third. Now, each of these derivatives are easy because they're all just linear functions with a coefficient of 1, so our derivative in each case is just 1. So instead of even putting the 1, I just said, well, a factor of 1 is irrelevant, and I just have x minus 1, x minus 6 for my first product. My second one, that term is going to become a 1, and I'll have x plus 4, x minus 6. In my third one, that factor is going to become a 1, which means I'm multiplying x plus 4, x minus 1. At this point, all I did was I FOILed out each of my binomials multiplications, and I got x squared minus 7x plus 6 for the first group. I had x squared minus 2x minus 24 for the second group, and x squared, it'd be plus 3x minus 4 for the last group. At that point, just collecting like terms, x squared plus x squared plus x squared is 3x squared. We have minus 7x minus 2x for minus 9x, plus 3x gives us minus 6x. And then for the constant, I would have negative 28 plus 6 gives me negative 22. And you can see yet again, Achieved liked that answer. But again, it should not have liked my answer for 15. That one's still bugging me. Number 18. 3-term product again. You're like, John, no problem. Right. You can just say it's just the derivative of the first times the second times the third, plus the first times the derivative of the second times the third, plus the first and second times the derivative of the third. Now, we know that the derivative of any exponential function is just that exponential function. So what I did from this step to this step, yes, I took the derivative of e to the x as e to the x, but then I just went ahead and FOILed out those two binomials. I knew it needed to be done at some point, so went ahead and did it. In the second one, I'm going to have e to the x times the derivative of the second, which is 2x, times the third, x plus 4, plus e to the x times x squared plus 5 times the derivative of the third, which is just 1. Now, the only thing I did from the third step to the fourth step here was I distributed my 2x through this group, and I had my 2x squared plus 8x. Everything else pretty much just pulled down from the previous step. Now, at this point, I need you to understand each one of your 3 terms all has a factor of e to the x. So since it all had a factor of e to the x, I can take out the greatest common factor of e to the x and say, once I factor out that e to the x, what am I left with? Well, in descending order, you're going to have an x cubed, and then you would have 4x squared plus 2x squared plus 1x squared for 7x squared. You would have 5x plus 8x is 13x, right there. And then your constant is going to be 20 plus 5 for 25. Fully factored final format of the fantastic answer. Now, up next, you're thinking, hey, we want to see a quotient again. Why, sure. Although this one's a little on the easy side. Anytime they put the exponentials in there, you know you don't really have to worry about those because the derivative of the exponential is the exponential. And you can say, well, for f of x, that's equal to e to the x over 5x plus 3. The quotient rule tells me square the denominator. Then bring that denominator up to the numerator times the derivative of the numerator. But the derivative of e to the x is e to the x. So this is your low d high minus high. The high function is e to the x, d low, times the derivative of the denominator. Well, the derivative of 5x plus 3 with respect to x is 5. So now I see I have my numerator done, but it's really not in a good format. So I can see, okay, what does my first and second term have in common? They both have a factor of e to the x. I factor that out. When I do, I can say, well, what's left over? I'll have 5x and then plus 3 minus 5. So plus 3 minus 5 gives me 5x minus 2, all multiplying e to the x. I get my fully factored numerator over that denominator of 5x plus 3, quantity squared. And that is precisely how Achieve wanted your answer. Now for number 20. We have in this one a problem in which gives us the product of two quotients. Now, you could work this problem as is, and it would be a pretty involved problem. But they recommend here, hint, simplify first. And that's always an option in these problems is if you can ever do any algebra, probably should do it. It would make it an easier problem. And that's the case here. So I went ahead and wrote out z squared minus 9 is z plus 3, z minus 3. Z squared minus 4 is z plus 2, z minus 2. Of course, I had my two denominators, so when you multiply all this across, all of this is one numerator, all of this is one denominator. Now we know we can cancel out common factors between the numerator and denominator, so the z minus 2 cancels out, the z minus 3 cancels out, and we're just left with z plus 3 times z minus 2. This is equal to our original function as long as you remember the two domain restrictions that z cannot equal 3 or 2. Now, as long as z is not equal to those two values, this is equal to our original function, g of z. So then I can say, well, all right, if I try to take the derivative g prime of z, now I could have really did the algebra first and said, well, why not go ahead and FOIL this out and then take the derivative? You could have, but that would really take all the fun of the quotient and product rule out of it. So I left it as a product and I said, derivative of the first is 1 times the second plus the first, now times the derivative of the second, which is again 1 with respect to z. So then you just have z plus 2 plus z plus 3. That gives me 2z plus 5. And I know what you're thinking. You're thinking 2z plus 5. Well, that answer was 2ez. Yeah, it was. That was not a good pun. But I still like it. Even bad puns are good puns. 21. We're looking at the derivative with respect to x. I like this problem. Now, first of all, please understand the differential notation. Unlike number 20, where it named the original function, this original function was g as a function of z. So its derivative was g prime of z. This function has never been named. It's not named f, it's not named g, it's not named h, nothing. It's just giving us some relation here, and it's telling us to take the derivative with respect to x on it. So as soon as I take the derivative with respect to x, that d dx disappears. This is not a function, it's an operator. This is telling me to take the derivative with respect to x. The reason I mention this is because oftentimes I'll see students want to put like d dx is equal to something. That's horrible. That would be like saying division is equal to 5. ddx is an operator just like multiplication and division are operators. As soon as that operator has been done, it goes away. So as soon as you start taking the derivative here, that ddx notation disappears. So derivative with respect to x of this group is, as soon as I do the quotient rule, no longer will I write ddx. Now, I can say the derivative with respect to x of that group is, I square the denominator, x to the 8th minus a. And I need to remember here in this problem, and it's right up here in the on the achieve, a is simply a constant. It's just another letter that we're not taking the derivative with respect to. So I squared the denominator, and then I brought that denominator up to the numerator, times the derivative of the numerator. So you can say, well, and think about this. What if instead of ax minus, what if that was 5x minus 7? You can say, oh, well, if it was 5x minus 7, the derivative would be 5. Same thing if it's ax minus 7. You'd say the derivative here is the power rule. The 1 comes down, multiplies the a, and then you'd have x to the 0. So you say, well, that's just going to be 1a x to the 0. Then it's going to be a. And then, of course, derivative of 7 is 0. So we get the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. Derivative of that denominator, I'm taking the derivative with respect to x. So this is going to become 8x to the 7th. And now I need you to understand why I had an a here when I took the derivative of the numerator. But then some students will say, well why is the a disappearing here? Because it's just a constant. Derivative of any constant is 0. The only reason that that a stayed in the numerator is because it was the coefficient of a variable of x. So I can say, okay, low d high minus high d low, derivative of the denominator 8x to the 7th. At that point, I need to simplify. I distribute the a through the first group. I get ax to the 8th minus a squared. I distribute the 8x to the 7th through the second group, and I remember to subtract everything. I'll get minus 8a x to the 8th right there. And then I'll get, it'll be a minus a negative, so it's going to be plus 56x to the 7th. Now, I notice I have two x to the 8th terms in the numerator. 1a x to the 8th minus 8a x to the 8th gives me negative 7a x to the 8th. And then I chose to put it in descending order with respect to x, so plus 56x to the 7th, and then minus a squared, our constant, all over your denominator squared. I thought that looked like a fantastic final answer, and that's matched what Achieve wanted. I really do not like this last question on Achieve, because they're wanting you to know a concept that has not been presented in the text yet. This is really using the concept called the chain rule that is not mentioned until section 3.7. You'll see I talk about it right here. So Achieve is trying to get you used to a concept before it's presented as a concept. They're saying, hey, we already know that the derivative of any exponential function is that exponential function, but sometimes there might be more to it. And this is trying to show you when there's more to it. So notice in their problem up here, they're telling you that if the derivative with respect to x of e to the 8x, they're saying if that is equal to e to the 8x times 8, well, they're wanting me to take the derivative of e to the 9x. Now, they're wanting you to draw the conclusion of, okay, well, the derivative of that exponential function was that exponential function. And then since the coefficient of the exponent was 8, hey, they're multiplying by 8. I bet I'll multiply this one by 9. That's what they're wanting you to make the connection of here. But the rule that they're really trying to get you to do is down here. If I take the derivative with respect to x of any exponential function, and let's say instead of just an exponent of x, you have some function of x as the exponent, then just like we've always said, the derivative of any exponential function, it is that exponential function. But then what the chain rule says is it says, yeah, it is that, but there's more to it. You multiply by the derivative of whatever is inside of the exponent. So you'd say, oh, okay. So in this problem, if I have e to the 9x, then I would say, well, then the derivative with respect to x of e to the 9x is e to the 9x times the derivative of 9x. And you can say, well, the derivative of 9x is 9, which is where I'm getting this from up here. And you can just say, okay, then your final answer is 9e to the 9x. Now, please keep in mind, this did not come into play in any of our earlier exponential functions. Any exponential function we had earlier, it would have had the derivative of its exponent being just 1. It was always just e to the x, e to the x. And any exponential function that we had anywhere earlier in this assignment, it was always just an e to the x. This is just showing you that it's not always so simple if your exponent has further derivatives within it. But now, I wouldn't worry about that until the gorgeous section that is 3.7. I just wanted to explain it so you could get this one problem in this assignment that they probably should not have included in this assignment. All right, guys, if you have any questions, let me know. There's some fun stuff here, and it's going to get more and more fun each section we go. I'm getting excited. I hope you are too. All right, guys, take care. Let me know if you need any help.